Hello and welcome back. I am continuing the stream project here of creating a moment of creating a LOGICSIM simulator for the Altair 8800 in C. I don't know why the camera's being a pain right now, but whatever. Well, it works. So as you can see, up in the corner up here, I have a live feed of camera directly to the Altair. And if I launch the program, you can see I can make it a little bigger for y'all. I can move things around now. Isn't that pretty awesome? Yeah, I think that's pretty cool. So yeah, I now have a live feed to the computer over there. Anyway, let's try to figure out what we're going to do now. Basically, Evan says I can turn this into a lookup table. Let me prototype this. Grab input. Iterate compare through list. Get index. Jump to function in array on index. I think that's what I need to do. So we have this. We have the input. Let me char in array equals hey Brett, I'm coding in C. I don't know if the scaling of the stream is messing with things, but yeah, I'm coding in C. And this isn't just any C, this is the original C. This here is the C book by Kerrigan and Ritchie. And this is the first edition. This is before ANSI C. So it's very similar. In fact, most everything is the same except very specific differences. Like, look here, you can't declare arguments in the function. You have to do placeholders and then declare them afterward. You have to declare all variables first in a function or in the scope before using them. Things like that. Or like things like, let me find for loop. I can't do like int j or int I. I have to declare int I and j first. It's just a few quirks that you gotta know beforehand. And yeah, Brett, this is what is going on? Who knows? This is programming for the 8080, the Intel 8080, which is a 50-year-old chip. Yeah. I have the ANSI C book. It's on my shelf. I use it, but usually I'm playing around with old computers. yo, LOGICSIM, what's that mean? But Brett, yeah, this is the 50-year-old processor for a 40-year-old computer. It's 2 megahertz, 64 kilobytes of RAM. I'm trying to fit everything down. And right now I have the binary down to 14 kilobytes. Anyway, so we're going to grab the input, which we did. I'm going to iterate through a list. So let's go up here and make the list. So I want A, O, S, X, R, N, D, W, greater than sign, and Q. So what I'm going to do is comment. There we go. Iterate through the list for int I, char I, yeah, for I equals 0, I less than size of in array, and size up I think is in array. Because it's bytes, I think it'll work, and it's not a pointer. Plus I. Cool. So I got to compare them now. I got to compare these two things. So if input equals in array I, break. So basically I'm going to grab the index of this. So if I hit X, then the index will be 0, 1, 2, 3. It'll be 3. Thanks. Damn, very impressive. It's nice to see the older style. I like C++ a lot. Unfortunately, for college learning in Java, is processing I'm learning Java processing, which is clunky. Processing is clunky. I know what you mean. I used processing a lot with Arduino. Obviously, so I didn't program the Arduino with processing, but I used a processing sketch to be paired with the Arduino, and it was very nice. And I'm sure there's so much more stuff now, but you can do crazy stuff. I did OpenGL, I didn't know OpenGL. The processing library did it all for me, but you can do so much cool stuff with processing. So just don't knock it, but I do know exactly what you mean. It is pretty clunky, and Java's pretty clunky nowadays too. The only reason to use Java is if you're modding Minecraft, in my opinion. And even then, people use Fabric and stuff for other things. Yeah, if you want to get into C and C++, really low-level stuff, you kind of got to do it on your own, unless you find a very niche job that you're, doing that sort of thing. It's really awesome. And Brett, I don't know if you're aware, but the shorts on my channel, the very recent, very recent shorts are basically the code, or the output of this code on my old computer. Okay, so then we're going to make a lookup table, and I'm going to cheat here. I'm going to go to Gemini. How do I make a function lookup table so I can do functions based on an index? We're cheating, folks. So, you know what? Let me look at my previous code here. Now let me look at my previous code here. Nope, never mind. Function lookup. Can you do this with no struct? I just want a simple lookup. Okay, so this is it. What we need to do is make a function table. So let's do that, folks. If you've never done this in C, you may not run into it a lot, but it is very helpful, and this is actually the start of making C object-oriented. And Brett, I don't know if you're aware, but my terminal library I wrote for this program, the one that is making this screen right here, that is object-oriented C that I have written. Anyway, let's do it. So let's say function table for edit device. So what we have to do is we have to do that because Aztec C doesn't take any arguments. Didn't you show me this sort of with type def? Here we go. This is what I want. So we're going to get rid of this. And instead of function pointer, it's going to be add dev pointer 1, 2, 3, 4, 5, 6, 7, 8. Also Brett. And then was listening is the Aztec C compiler only lets you have variables and function names with 8 characters max. You can't have anything longer. You can't have anything longer. So anyway, now I'm just putting this over here. So this is going to be edit dev pointer, add dev table. C without having namespace structs containing only variables and not functions always confuses me how to make it object oriented. Yes, and let me. There's so many schools of thoughts on how to do this, but surprisingly, it's not that complicated. You can get the very start of object oriented code going very easily, and I'll show you exactly how I do it. I'm not a master at this. And there is a paper called ooc.pdf. Search it up. It shows you how to do object-oriented code in C, and it's a very good read. This is what I do. What you do is you have a struct. This is going to be your object. Okay? You have your variables, and then you have function pointers. Because a struct is a struct is a struct. You can have anything inside of it. You don't need to have variables, but remember a variable is a pointer, is a function pointer, and a function pointer is a variable. It's the same thing. Void is a data type. So you have a pointer to a function name, and then you make up a bunch of functions. I have a very obscure name, so I never accidentally use them. And then in your initialize function, my init term, which is your constructor, your object constructor. This is all C++ does, or at least it used to, is compile down to C in this way and do it. Your constructor will be init object. You give it the address of the object, the struct, any parameters you want to use for initialization of the constructor, and that's where you set your function pointers. You set the object's function pointers to your existing function, and you can override them. You can switch them later. Polymorphism. It opens up polymorphism. It opens up inheritance. There's so many things, and this here is just the surface. But this is it. This is the beginning. This is what the concept of object-oriented programming was. And you can do this in assembly. There's actually articles online of how to do object-oriented code in assembly. It's nuts. If you think about it, you can. It's just, do you want to? Yeah. No, it started in C. C is pointer. Everything is pointers in C. And pointers are so powerful. Pointers, double pointers. I've never seen anyone seriously use a triple pointer. I have used a triple pointer in one of my streams. A few streams ago, I have done, I made a tensor in C in Windows 1.0, like in DOS. I did a stream on that because I want to do like an AI thing. But yeah, anyway, let's make the functions. Excuse me. That's what we're going to do. I'm going to take this. We're going to copy this. We're going to go all up in here. Right here. I'm going to paste this. Okay, so I need void. Let me just use the void, okay. Void, and setup 1, 2, 3, 4, 1, 2, 3. Okay. Device, and then device, and then I can do that. Look at that. Boom. There. Look at that. Now, what I have to do is I just have to make all these functions. I gotta leave and get some rest, man. Get down with the nasty files. Take this. Oh, man. I'm sorry, Brett. I hope you're feeling better soon. Get well, get well. Yeah, no. Thanks for checking in. I'll be here. I really enjoy this stuff. Get well, man. Then I will just set these all up. Or up. Yo, H-Man, you still there? This is going to be signal. See, 1, 2. Let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Let's see. 1, 2, 3, 4, 5. 2, 3, 4, 5. Let's do signal. I'm doing this while I'm listening to the Stranger Things soundtrack. It's really good. Gotta finish that show at some point. Okay. What is this? NAND. NAND gate. What is this? NOR gate. I really should finish that assembler. I just got bogged down in code and just kind of gave up. I really don't want to give up on that. That's so close to being done. And then once it's done, I want to do the compiler. Okay. Let me run back down here. Okay. Basically, check if skip quits, if input equals Q, return. Cool. Check if just editing value. If input equals, go to div val 1 2 3 4 1 2 3. Break. I think I can do a return inside. Input equals or continue. Then obviously I should optimize later. Yeah, I don't know. This do while loop is kind of sus. I feel like the multiple checks for Q are kind of nuts. Anyway, jump to function table. So let's do that. So let's go all the way back up. We're gonna do this. and of course and or signal. How much you guys want to bet this actually builds on the first one? Yeah, it's more not. Okay. I'm going to jump the function table. And then this is called div table I let's put the scope out here. Cool. Put the scope out there. And then we want to pass device let's try building it, you know, let's try building it. Okay, what was this? Aggregate, no, auto aggregate, initialization allowed. Is it gonna be this again? Yeah, okay, it worked. Now let's do the stat. 120 records. The binary raw is 12 kilobytes, 96 records. That's pretty cool. Now let me close it. Erase logicsim.com, pcget logicsim.com. Let's send it over. And as you can see, the lights are blinking on the machine. That's because I'm sending it over, and if you actually look at it's sending, I think, in like 1K chunks, and every time a chunk is received, you see the big light flash. Okay, let's try running it. Well, it's done something. Let's head over and try to edit a device. Well, folks, that didn't work out at all. Let me look through here. Okay. What is an array? 1, 2, 3, 4, 5, 6, 7, 8. Let's try that. Let's make log C. LOGICSIM.com, pcgetlogicsim.com. Sending. Man, what we got there? Who's watching and why are you watching? I'm very flattered. Okay, let's head over and see. Why is this not working? It's now frozen. It's not frozen. It straight up broke. Okay. Like as you can see, it just straight up broke. What is going on? Let me try doing this. Okay, let's try building this again. Really? Okay, let me figure this out. Input. If input equals in array 0, break. It breaks out of the for loop. No. Right. No, break. And then do this. I gotta wrap this up in something else. Okay. Clear, fill over screen, add a nest, grab input. No. If go to edit the table 1, 2, 3, 4, 1, 2, 3. Cool, right there. I have that label right there now. Then break out of the loop. Once I've broken eight, 9, if not input I 9, else so basically what's happening here is if you have gone off the end of the allowed gates 1, 2, 3, 4, 5, 6, 7 0, 1, 2, 3, 4, 5, 6, 7. If you have gone off the end of the allowed inputs, then that means your input wasn't gate, and it wasn't quit, and it wasn't skip. So just return. Let's try that. Okay. Let's try this. Let's take a look up here. Let's try running it. Let's try. I believe it works. Look at that, folks. It works. I got it working. Let me see if the simulation works. Well, wait 1 second. Okay. So as you can see, it has frozen, and it froze because why did it freeze? I mean, it completely got borked. Brutal, bro. Yeah. I mean, it completely bricked. As you can see, this is like BDOS error blank on select. So basically, I have overwritten the operating. My code has messed up so bad it has overwritten the operating system. So let's reboot the Altair. Okay. Okay, I think it's working now. Okay. Okay, let's just try a simple simulation and see if it works. I don't know why it broke like that. Gonna be honest. Okay, it's low. Edit. Next. One. High. Low. High. Okay. Simulation works. And the XOR gate works. I don't know why it broke so brutally. I don't know. Huh. Well, I'll have to think on that one later, I suppose. Well, let's look at what Edmund says next. Edit dev could use a lookup table, not a stack of if-else statements. The main could use a lookup table for processing characters that move the device around the screen. If you start getting really byte hungry, your initialization could be memcopy as a predefined block of bytes rather than having a long set of copy instructions. Are you planning scaling devices going further with all the changes? So basically he's saying to remove malloc. But that's at some other point. You'd have to do your own memory allocation routine. My own, the going space crazy, I don't think I need to, but I will if I want to, or if I need to. Main could use a lookup table. He says that the lookup table in main could be this. Like have this as a lookup table. So instead of a function, let me prototype this. Hang on, let me think. Let me think. I could, well, I could but it's so trivial. I don't think I want to. I could do a lookup table of like 8 ints or 8 chars, and based upon an input, add the index to X or Y. But I think the overhead code will just make up for it all the same, and there's no use. There's no use in that. What I will do is I will add the final gate, so I can show you guys what it takes to add a gate. We need to add. We should add the XNOR, and you know what? Let's add the XNOR and add the NumPy. Let's do that. Okay, so let's take the XOR. Okay. We're gonna add one right here. One, two, three, four. 1, 2, 3, 4. And we're gonna add 6 lines. We're gonna add this to the lookup table. Okay. Sounds good. We'll add a wire too. We'll add a wire device. But see, the important thing here is the bow. I'm gonna add the bow to it, or the negate circle. Let's do that. 1, 2, 3, 4, 5, 6. Cool. And let's delete that. Let's do this. Void here. XNOR setup. Device. And then let us just add this on. And let's just make sure XNOR gate. Cool. There's all that. Let's take this. Cool. Oh God. One XNOR Z. Cool. And then let me add this to the logic. Dude, this shouldn't be a lookup table. This should be, or this should be a lookup table. This is probably not the lookup table I want. I think Gemini's suggestion of doing a lookup of a struct table and setting that is would be better, but again, the code overhead might just not be worth it. Here we go. Case Exner Gate like, where is the XOR? One, 0. Let's try building it. Why is it this few microseconds? True, I do need this microseconds. It's not really the microseconds I'm worrying about right now. I'm worrying about the size. I'm trying to get the size of the code as small as possible. I'll show you how big it is. Of course it didn't work. What is this? Line 545. Why didn't it work? What? Why didn't it compile? Hang on, what? Duplicate case and switch? Oh, duplicate case and switch. It is 15.125 kilobytes. StatLogicSim.com. It is 121 records. Each record is 128 bytes. StatLogicSim.o. StatLogicSim.o. And the O is the object file. It's 14 kilobytes, 98 records. Let's just try running it, you know. Let me see. I'm gonna head over to the computer. Quit it. Okay. I'm gonna head back over here. eRay. LOGICSIM.com. pcget LOGICSIM.com. Why, thank you very much. Yes, it is very crazy. I'd like to say myself. 15.125 kilobytes for a graphical logic gate simulator, and not just, you know, one gate at a time. You can draw a full system. You can, I had a short where I did a full adder. Now let's just see if it works. So let's get over. Let's do a half adder. Let me go simulate a half adder. Okay. So we have, we have the XOR gate is 0, and then the AND gate is also 0, and I'm going to add 1 plus 1. I'm going to set both inputs to high, so the XOR gate should be off, should be 0, and then the AND gate should be high, 1, being binary 2. So we have a low XOR gate and a high AND gate. It works. So the simulator still works. Now, as you can see, the drawing is, well, it's rather slow. That's the terminal capability of this machine. That's not me. My code is as fast as it can really get. So the terminal that runs in this emulator is a separate board entirely and a completely separate chip. And that firmware's code allows you to draw pixels on, pixels off, or pixels XOR mask. So toggle whatever is there. That would be incredible. Problem is, all the drawing is hard-coded to be pixel on. So even though it has the stuff to do the other stuff, it can't do it. So I'm going to have to go into the source code, add a couple flags that you can send using, the VT100 terminal codes, so I can, instead of having to erase the entire screen, I just will redraw the same gate over top, but negative, so it'll delete itself. Yeah. Anyway. So that's pretty cool. Let me see if Eben has said anything else about what to do. Again, the edit div probably isn't the right, it's not the right lookup table. But that's not the right lookup table. SimDiv, are you simulating logic or other circuits? So I think that's it. I think aside from some code cleanup, and it's making sure, indices don't run off and I just fall apart, I think this project's done. Or it's as done as I can get without rewriting the terminal code. And the problem of writing the terminal code isn't that I can't do it. I can. It's if anyone else wants to use my program, they have to reprogram their terminal too. And it's just not like a plug and play sort of deal. You have to have a microchip. You have to have a microchip pick programmer. You have to take it apart. You have to. It's just not like a plug and play like the Arduino is. But yeah, I mean, it's kind of done. After all this time, it's just kind of done. Well, before I leave, I can add the cursor to the connections. Let's do that. So how long have you been working on it? How long have I been working on it? Let's look. So if I go to my YouTube channel, this particular code, new channel, shorts, this was description January 5th. So that was almost a month. I think I worked on it like a couple days before then. So I think almost a month I've been working on this code, this particular code. That's nuts. It felt much shorter. But I did this from scratch. The help I've had was how to optimize it. It went from about 24 kilobytes down to 15. It'll be a little bit over 15. It might be 16. And of course, I don't have scaling right now. I don't have scaling because I got rid of floats. But if I wanted to, I could talk to Eben about how to do fixed point math with my own library, and I very well might take him up on that offer, because I think learning fixed point math is a good exercise anyway. Yeah, I'm pretty impressed with it myself. It's on Git. I don't know if it's, yeah. I mean, it's on Git. Let me go here. How do I settings? Oh my god. How do I do a server invite? No. Darn. I don't know how to do it, but I will. If you want a couple of my my gardening video, my most recent gardening video, I think I have a server invite link if you want to join the after hours programming server. So yeah. Anyway, before I do that, let me sit down. I'm already sitting down. Let me try to draw this cursor. So I need the start point and the end point of the connection, which is right here. And you know what I'm gonna do. I'm gonna cheat. Wait, do I even need to cheat? No, I don't. Well, kind of, but... There. Expired. Let me really quick that server invite link. Discord. Inbox, show member list, threads. Am I just stupid? Invite people. Copy. Hidden use copy button. I mean, am I just a boomer? hidden use copy button. What? Am I just a boomer? Invite people. What? I'm so sorry, guys. Okay, you know what? After this goes live, I'm going to go into the description. I'm going to try to add the link because I don't know why I can't. I have no idea. I'm just a failure. So CDY1, CDX2, CY2. Are you clicking the huge copy button to the right of the URL, lol? I am. But when I do invite people, the URL literally says hidden use copy button. And I hit copy, and then I hit paste anywhere, and I copy. I'm pasting the text, hidden use copy button. I must not be understanding anything. Gotcha. Is there a way to disable streaming mode? Okay, let's try that. I hit disable streamer mode. Invite people. Here we go. You're right. Discord invite link. Please join us. Yeah. I think I enabled streamer mode again because it crashed OBS. So I might crash. Hey, Des, what's up? Yo, man. Yo. Yeah, we had a couple active people. Insky was pretty cool. And then he left. I'm very sad. But yeah. Okay, I'm trying to think on how to basically for code wise, what I'm gonna have to do is I'm going to have to use this code again. I'm just going to take this code and just use it again down here just to generate the I just need to find the XY position to draw the cursor at. But as you can tell by my speech, probably I'm getting pretty tired and I need to sleep for work. But anyway, we got it working. We have optimized things with the jump table, with the lookup table, kind of. I might do that a little differently. We've added in the last Boolean gate aside from wire and imply, I think that's it. And that's it, really. Just gotta squash some bugs as they come up, but that's it. This project is done, and hopefully I can go back to the assembler. I would love to go back to the assembler and finish programming that, because from the assembler comes the compiler, and I would love to make my own compiler, because that sounds awesome. Anyway, yeah. I gotta head to bed, and yeah, thanks, man. I'll head to bed, and I might stream tomorrow, possibly. If not, I'll stream again this week. Okay, well, see y'all. Have a good night, man.